video is our first set of notes for Unit 7, which is going over cube and cube root functions. Sorry, just let my dog out of the room. Anyway, cube and cube root functions. I've already got the notes actually written out because I recorded this earlier, but the audio didn't record. So I'm re-recording, so you have the picture and audio, but everything's already written out. But I'm just going to walk you through it. So we are just practicing using technology today. That's Desmos on your computer, to be able to use Desmos to graph these functions. Just making sure you know how to input everything and interpret it to a graph. We'll talk about the details in the next sets of notes over the next couple days. So you can see here, I will split screen and show you what I typed in Desmos. So this side, the first two functions here, these are what cubic functions look like. Okay, so it looks really similar to a quadratic. The only difference is your exponent is a 3 instead of a 2. So it's cubed instead of squared. Okay, so when you're typing that in, you do the same thing. Now on your keyboard, when you do squared, you may have used this button. You won't be able to use that for cubed, but you could use this one and type a 3 in. Or on your actual keyboard of your computer, you can use the little caret, like Shift 6, and it'll raise up to a power and you can type your 3 in. So I've typed this equation in, x plus 4 cubed minus 5, and you can see the graph over here. Okay, so you'll start to see a kind of a pattern of the shape of these. And like I said, we're going to talk more about it in the next couple days. But the cubic functions have this general shape, a little squiggle here in the middle. They don't actually change direction. This is increasing always, but it's got this point where it's called a point of inflection here in the middle of our graph. So that point of inflection is at -4, 5. So when I go to fill in my table to graph this, I like to put my point of inflection in the middle and get a couple points to the left and a couple points to the right. I know this said at least 4 points. I would always do 5 points for cube and cube root functions because you have the center point, that point of inflection, and then I would get 2 points to the left and 2 points to the right. So you've got a pretty nice grasp of what the curve is supposed to look like. So I put that -4, 5 on my table first. Now you can get an actual table, put your cursor in the equation that you want a table for. Remember, you can just go here to edit the little gear symbol and it'll let you create a table. Now the table's automatically going to populate from -2 to 2 for your x's. So I know I want points to the left of that to be able to graph. These are way too big, not going to fit on my graph. So you can clear this out. You can type, or you can just go type below it down here. You can add whatever numbers you want. So I'm going to go a couple points to the left of that point of inflection, and then the point of inflection, and then keep going to the right a little bit. So I got -6 to -2 for the x values that I wanted to plot, and you can see those points pop up here on the graph too. So that helps you see it. So I put those on my table. That's where the values that I've written down came from. And then I go and plot those points. And you can see these three look almost, when you just plot the point of inflection and the point to the left and right of it, it almost looks like it should just be a linear function if you only plot those three. So that's why you want to make sure and get another one further to the right and left, because it is not a line through these. See how it curves through all of these points and then continues to increase that way. So I've got that on my graph over here. Plotted those points, and I've gone ahead and circled the point of inflection there in green. So that was the point of inflection. Then I got 2 points to the right, 2 points to the left. That last one to the left, -6, -13, would be about down here. It didn't fit. So I just plotted 4 for that one. So then I did the same thing. Okay, you should give it a try and see if you get this same graph. Make sure you can type this in. You know how to get a cube in Desmos on your technology. Okay, my point of inflection on my table, and on my, I could see it on my graph, and so I got my table, and it was at 5, 0. Show that one. Turn this one off. Get rid of that table. So here's that second equation. You can see it's over here, and I could come here and figure out that point of inflections at 5, 0. That actually happens to be the x-intercept as well. So my point of inflection, I'm going to come over here, I'm going to add a table. And I know I want that point of inflection and a couple points to the left and right. So I want 5 to be in the middle. So I'm going to start it. I'm going to go 3, 4, 5, 6, 7. So I've got 3 to 7. Those are the 5 points that I put on my table here and that I plotted on my graph. And you can pause this video if I'm going too fast and get it copied down onto yours. Now, when you flip over to the back, this is where we get into the cube root. You'll notice the shape of the cube root functions is similar, but it's like it's turned on its side almost. So let me get rid of that table. Turn that one off. So here is this first cube root function, for example, 3. Now to get cube root, let me actually show you how to type that in, cube root of x plus 2. So you can't use square root. This is the square root. Notice there's no number there. And if I type that, it doesn't give me the option to type a different value there for the index of the radical. So I've got to come over here to functions and go all the way to the bottom. All the way at the bottom, there's the nth root. The n is in the index spot, and that will let you type whatever index you want. So I want the cube root and then x plus 2. So that's how you get your cube root. It's under functions all the way at the bottom. So once you type that, you can see again my point of inflection. So then I want to make a table. And I want that point of inflection at the middle of my table. So that point of inflection was where x was -2. So let's try starting at -4. Oh, well, -4 is a decimal. I'm not going to graph that. Let's try -3. Okay. There's the point of inflection. Okay. And then notice when I keep going, I get decimals again. So I'm actually going to extend this out and keep going until I see another integer to plot. Oh, there it is, 6. So my table here, I had my point of inflection in the middle, -2, 0, and the point immediately left and right of it were integers, but then I had to skip all the way to +6 before I got another integer value for my y. So then I could do the same thing going backward past -3. -4 was not an integer, so I'm just going to keep going. -5, no, 6, -7, -8, -9, -10. There it is. So that's where the -10, -2 came from. I just kept going until I saw another integer. So I could have 5 points that are all integers and easy to plot. And all 5 of those fit on my graph here. You can see I have the point of inflection, and then 2 points to the left and 2 points to the right. And then I did the same thing for this last one. Here's what came out to. Okay, of my point of inflection. I can zoom in here to see that better. Is at 1, 3. So then you can just get yourself a little table. The x was at 1 was the middle. So immediately left and right of 1, I've got integers, but you can see then it's decimals again. So I might have to, let's see how far we have to go. Oops. To 9. So that's where I got 9, 5. And then I did the same thing, and I just kept going backward till I got another integer value for y. And that took me to -7, 1. So then I was able to plot all of those points and sketch my curve. Okay, that's it for today. Easy peasy. Just can I type it in Desmos, find a table, get some integer values to plot and graph the curve. So some of you are probably already noticing things that are carrying over from what we just tested on in Unit 6. And we're going to talk more about that, like the transformation rules and things in the next couple lessons. But that's it for this set of notes. And now you can go and do the Delta Math practice.